All right, today we are going to start Chapter 2, and Chapter 2 is all about exponential growth. It's a new type of equation, new type of growth that we're going to be learning about. And we're going to look and investigate it with the context right here. So it says, in the book of Mice and Men by John Steinbeck, two good friends named Lenny and George dreamed of raising rabbits and living off the land. What if their dream came true? Suppose Lenny and George started with two rabbits that had two babies after 1 month. And suppose that every month thereafter, each pair of rabbits had two babies. So we're going to make a diagram for this to see how this is growing. So in my diagram, I'm going to say x is equal to a parent and a circle is equal to a baby. And so we're going to have month here. And then rabbit here. So at month 0, that's how they start with. There were two rabbits to start. So I have two x's. And we can go down here, month 0, 2 rabbits. After 1 month, it was said that those two parents had two babies for a grand total of 4 rabbits in month 1. Now, if you notice, we have this pattern column over here, and we do not have enough information to determine that pattern yet, because to get from 2 to 4, I could add 2 or I could multiply by 2, so I do not have enough information yet. So therefore, I want to do month 2 now. This is where things get a little weird, because these parents are still parents and they have 2 more babies. However, these 2 babies are now parents and they have 2 more babies after that. So we now have a grand total of 1, 2, 3, 4, 5, 6, 7, 8. And now we can be sure what our pattern is. Our pattern is going to be times 2. Because 2 times 2 is 4, 4 times 2 is 8. And we can keep this going. Times 2, 16, times 2, 32, times 2 is 64. Times 2 is 128. Times 2 is 256. Times 2 is 512. Times 2 is 1024. So, what we know as we go to write our equation is we know that this equation is not going to be linear, because if you remember, linear equations are y equals mx plus b, and linear equations have a pattern of adding or subtracting the same amount. Here we're multiplying, so it's not linear. So when the pattern is multiplication, we have the following equation. Y equals initial value times your multiplier, and then your x is in the exponent now. Notice it's up top. And so our initial value is the y value when x equals 0. And the multiplier is our pattern of multiplication. So therefore, our equation in this particular context would be y equals, our initial value is 2, because the y value in x is 0. Our multiplier also happens to be 2, and then x is in the exponent. When you write an equation, you must have an x and a y in your equation. because that means I can plug any number of months in this case, and get any number of rabbits out, or the specific number of rabbits out for that month. For the second part, it says how many rabbits will Lenny and George have after 1 year. This is where I can then go ahead and plug the appropriate number in for X. So be careful, X is number of months. So after 1 year, I actually have to plug 12 in for X. And remember on your calculator, if you're doing 2 times 2 to the 12th, 2 times 2, exponent there. There we go, that is our caret button, exponent 12. 8,192. So it's growing fast, real fast. All right, so you are going to complete the other pages. The other pages do have you graph it. So graph what fits on in your other pages, and make sure you are doing a diagram, because it's not growing the way it seems to every time. So again, you're always making your month and your rabbits, and draw your circles and X's. So in this case, for case 2, we're starting with 10 rabbits. So I'd start with 10 X's. I would group them in pairs like I have here. So that would be month 0 is 10. And then after 1 month, each pair has 2 babies. So this first pair is going to have 2 babies. This pair is going to have 2 babies. This pair is going to have 2 babies. This pair is having 2 babies. And this pair is having 2 babies. And then count the grand total. Alrighty. So you're completing those next couple pages, and then we'll close it out with some general facts about exponentials.